Hi, Algebra 1. So we just did day 1, and you already did assignment 1. Now we're going to do the day 2 of the video. So let's go right away. So we already talked about the the population. We're going to look at table properties and graph properties of exponential functions. So first of all, we're going to look at the table properties. There's some interesting things that are going on in the table. So remember we had our function, our a was our original value, b was our growth rate. Well, what's happening is in our table, you'll see that with the 0, that's just our original starting value, a. Right? After 0 years, the population of Columbus was the population that we said it was, and then it grows at that growth rate. So after 1 year, what we did was we plugged in 1, y equals ab to the first. So that's essentially how we got that one. In the table, you'll notice that we multiply by b again and again and again. So if we did year 2, we would have y equals ab squared, which is b times b, that part right here. That's how it's the same thing. That's how exponents work. Same with the a cubed. And the third year, we'd have y equals a b cubed, which is b times b times b. So if you notice when we multiply by these things continuously, that's what an exponent is. So if we go to the graph is going to end up looking either starting off slow and then growing quicker and quicker and quicker, and then it starts going to grow fast, or when it's losing value, it sometimes looks the other way. It loses value fast, and then it levels off. So at some point, we always have this leveling off thing, either at the start or at the end. So if we go back to our population of Smithville, you'll see that we start with 35,000. So in my table, I'm going to start with 35,000 in year 0. Then after 1 year, well, we're going to plug 1 in for x. So we can do that with our calculator. So we start with our 35,000 in Smithville, and it's growing at a 1.024 rate. So times 1.024 to the first. Okay, I'm going to do all the calculations right now, and then we can plug them in. You don't need to see me do this more than once. Okay, so there's what we got in our table. You'll notice that if you multiply from this row to this row, just multiplying by that growth factor of 1.024 every single time. And that's what it says in this little chart, right? You're just multiplying by another b every time. So then when we go to graph it, we're going to need to label our scale. So down here, I've got 0, 1, 2, 3, 4. And then on this scale, I need to look at, I have 35,000 to 40,000. So I would have to go up by thousands. Now it's not looking like it's growing by very much, so we're at the leveling off point. Okay, so here I have my axis labeled. I go up by 5,000, 5,000, 10,000, 15, 20, 25, 30, 35, 40, 40,000. So at 0 years, let me change my color, we have 35,000 people. And we know that our population's increasing, but not by that much. So then we got 35,840. Then we got 36. Again, these are just an estimate. It doesn't have to be a perfect graph. 37. And then we get closer, and we're moving up. So right now it kind of looks linear, but we know that the population's growing, and it's kind of growing like this. So it's going to start getting that curve that we're looking for later. Now let's look at Marissa. Marissa investing the $300. So we're going to do the same thing. Again, I'll show you one on the calculator, and then I'm going to fast forward till we have the rest of them. So we have 300 times 1.05. Well, that's just going to start off at 300 after 0 years. And then hopefully her money grows pretty quick. 1.05 to the first and the second. Okay, so there we go. You can see how the money's growing. At first, it was growing by $15, and then it grew by slightly more than $15, and then again, that's more than $15 again. It's starting to grow by a little more every time. So when we go to graph, we need to label our scale again. This is years. And then the Y scale is going to be money. I'm going to go ahead and label it and then fast forward for you again. Okay, there we go. Now I have my graph all labeled. We have our years and we have our money going up by 50s this time. So I'll go to graph. I'm going to start at 0 and 300. After 1 year, it goes up to 315. And 2 years, 330. 3 years, 347. And 364. So again, it's hard to see, but it looks kind of straight, but it's actually starting to bend. It starts and it's bending a little bit up, 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 and then it's going to curve and start going up faster and faster and faster. Okay, then we'll look at our cars, our last one. So with the cars, it's depreciating, so the car value goes down. The car value starts at $25,000. That's how much it's worth, and then it's going to go down pretty quick. So again, I'm going to use my calculator. I'll fill in the table. I'll show you the first one, and the rest is up to you. So 25,000 times 0.85 to the first. Okay, so now we can look at our table. So it's depreciating, the value is going down. So it started at a $25,000 worth of car, and after just 1 year, the car is only valued at $21,000. It keeps decreasing, but it actually slows down how much it's decreasing. So again, I'm going to set up my scale. We're going to have years, and again, I'm going to skip forward. All right, so now I've got my years and my car value, my scale, my axis is all set up. I'm going to start at 0 years. I have our $25,000 of car worth. And then it decreases. After 1 year, we're at 21. And 2 years, 18. 3 years, 15. So this picture is probably the best one yet, where you can see the curve. It's leveling off. Not that your car is ever going to stop depreciating, but it's going to start depreciating less and less each year. So that's where we got our exponential functions. It would start way up here and go back down. All right, please fill out the fun page and ask questions. Do your best. This should be pretty easy. It's a lot of calculator work, and we'll help you out whenever you need it. Okay, bye.